I'm Frank McSherry from Materialize, and I'm going to be talking to you about how you can affect behavior in SQL systems using declarative constraints between your data and time, which might sound a bit abstract, so I'm going to talk you through some examples which I hope make the point a bit more clearly. We're going to start here in Materialize. This is a SQL system that does some interesting things. It does some not interesting things like create tables, and you can put records in tables, and these are sort of standard SQL things. You can issue queries against tables, again, fairly SQL-y sorts of things, just showing the results of tables and queries against them. And you can also do some pretty horrible things. Here, for example, is a count of a correlated outer self-join where the join condition is a correlated subquery. The answer is 3, and I have no idea what the query computes. Now, some of the cool things that you can do in Materialize that are maybe non-standard are to observe not only the contents of tables, queries potentially, but also get live change logs to them. So what we're seeing here is the verb tail in Materialize. And when you tail something, the subject of the tail, it's going to give you an initial consistent snapshot of its contents, which we can see here, the records 1, 1, 2, 3. At a particular time, these are milliseconds since 1970, and this record here is the number of occurrences of the record that follows. So we're seeing here 1, 1 and 2, 3, both in the snapshot that we managed to take at this particular time. If we go and change the data at all, so we can just add a few records to foo, we'll see that at a time, the same time, in fact, some more records are added. This is because the insertion happens transactionally. 1 copy of 4.4 over here, and 2 copies of 5.6, which is totally correct. We added 2 copies of 5.6. So generally, we'll be able to see arbitrary integers over there as we add, update, remove things. The easiest way to see that, actually, is to check out another cool property, which is that we can tail views or queries over these collections. We're just looking at the count now of foo, and the initial answer is 5. It's a collection that contains 1 record, 5. As we add more data to foo, the count is going to change, and you can see it immediately changes transactionally at exactly the same time from 5, so -1 copies of 5, and 1 copy of 8. So the result now contains exactly 1.8, which is indeed correct, having added 3 copies of that record up there. This isn't just for count. You can sort of imagine how we might do this for count. It is more general than that, so we can monitor any of these horrible things. This is that same filthy outer self-join with a correlated join condition whose value is initially 15. As we go and change the data, it updates from 15 to 17. I am told that is the correct answer. No, we work quite hard to make sure that we produce only correct answers for you. So this is interesting. Materialize's data model, right, is that these collections, foo, and views defined over it, evolve through time. So at every moment in time, they have some contents, and as time changes, advances in particular, those collections may change their contents, and you get to see the results when that happens. Can we look more directly at this notion of time? And the answer is yes. So to see that, let's dive back into select land. So this is a query where we've selected out the A and B columns, but also the logical timestamp, which is just a function. In the context of a query, it is the time at which query is being evaluated. It's like now in Postgres or something like that. So it's the same value for all these rows because this query is being evaluated at one time. But it's, in the moment, just a column here, right? You might say, wow, that's really cool. Can we manipulate it? And you can't write to it. It's not an L value in that sense, but we can do something very similar, which is use it in constraints. So here's a query. The query has no results, unfortunately. But what this query does is it's exactly the same query. I've added a new constraint. The constraint says, make sure to only keep rows that are not too old. What does that mean? The logical timestamp shouldn't be bigger than 5 seconds plus whatever this B column is. Now, there are no results because we've been putting in numbers like 1, 2, 3, and 4 into here. But we can imagine putting in some data that have the current time, current milliseconds since 1970. And if we issue the query again, we'll see the result. And you can totally check this out. If you look here, this is B, you add 5,000 to it, compare it to MC logical timestamps, it should check out that this is smaller than this plus 5,000. Yeah, cool. If we issue the query again, it's not there anymore, which also makes sense because in the meantime, MC logical timestamp has increased, and that constraint is not satisfied anymore. What's really cool about this is that the answer to this query has changed even though the data itself did not change. So something else has caused a change to happen in the results of this query. To investigate this, let's run back to our tail verb over here, which is going to allow us to monitor a query. And I've got the same query. Actually, it's a little bit of a cheat. I'm not printing out MZ logical timestamp anymore, because if that's changing every millisecond, it would be very spammy. So in fact, Materialize just doesn't let you do this. But if we go and introduce some new data here, we see it produced in the output. And in just a moment, here we go, we see its retraction, which is sort of cool. Not only did we see, okay, we've seen records we added to the output before, but actually we've, in a sense, scheduled the retraction of the data by imposing a constraint here. This is, if we were to type select over and over again with this query here, we would, about 5 seconds later, see one fewer record than we had been seeing before. And the system is able to reflect on this query and say, I'll save you the trouble. Right? I know exactly when this record will drop out of your query, and I'll schedule this retraction for then. Very cool. So you might also notice that these two times are not the same. This is just the evaluation of that now function up there. It doesn't necessarily have anything to do with Materialize's current time. This is something in stream processing that's called late arriving data. It's annoying. We might have wanted the data to show up at this time, but if that time's already passed, that's too bad. We can't do it. Now, there's a technique for dealing with that in streaming systems that fits nicely into SQL also, which is what's called grace periods. You essentially take the constraint you were thinking of having, maybe that the data should show up at the time that's expressed there, and add a little bit of a slop factor to it. So we're adding a second worth of slop here. And that second worth of slop means that as long as the data aren't more than a second out of order, typically you'd use a bigger number, we're able to produce them at exactly the intended time, which is to say exactly 1,000 greater than the supplied data. All of our results are now 1 second delayed, of course, but they're at least precise for folks that aren't too out of order. So that's pretty handy. There's a bunch of cool streaming idioms that you can do just using these SQL constraints. You can do, these are continual slide windows, but you can do stepping windows, tumbling windows, all sorts of neat stuff just by rounding these values appropriately. Let's look at something that's a bit harder to do in streaming systems conventionally, which is the following. All I've done here is, we still have the constraint that it should be bigger than foo.b, but I've changed the upper bound to not be 5,000. I've said it should be foo.a. So this means that the validity interval is actually specified by the data itself. This is the number of milliseconds in there. So unfortunately, these are going to get retracted pretty quickly. But you can see, if you play back things in slow motion, that these were valid for very different periods of time. 9 milliseconds, only 201 milliseconds. Of course, you can make that be whatever you want. But the data themselves can specify their own validity, which is really cool if you're trying to work with data that have that property, certificates or something like that. And just to wind down, this is the scary query that had all of the horrible constructs in it. Let me just add some random stuff in there. This query, I contend, is continually being correctly updated subject to these self-defined validity intervals over foo, not bar the second version of foo. So we're joining windowed data with non-windowed data where the validity in foo is set by the data itself. This is all really cool, expressive stuff to do, and we haven't gone any further than just imposing constraints between time and the data itself, causing the system to schedule the behavior when it needs to happen as a function of the data. That's all I had to show you. Thank you, and I appreciate your time.